8085 microprocessor pin diagram lecture number 4. So today we are going to learn about externally initiated signals. Externally initiated signals are hold, resetin, ready pin, and as per this signal microprocessor give the acknowledgement as hlda, and for resetin it will give out the signal reset out. So first of all we are going to see hold pin. Okay, so this is our microprocessor 8085 and this microprocessor is connected to DMA controller. So what is DMA? DMA is the direct memory access block diagram. This is one of the circuit which is responsible to fetch any data from memory unit. So this DMA controller is connected with this memory unit, and whenever microprocessor required any data, that data will be fetched ahead of time from memory and make it available for the microprocessor. So this is the main task of this DMA controller. So direct memory access, the word itself explain you about this, about the functioning of this DMA controller. So here whenever this DMA controller fetching data from memory unit, at that time it requires address bus and data bus. But address bus and data bus belongs to 8085 microprocessor. So whenever this microprocessor not doing any work along with IO or memory unit, at that time it does not require this address bus and data bus. It means that whenever microprocessor is busy in processing some data internally, at that time it does not require address and data bus, because address and data bus is specially required for this microprocessor to communicate with this memory and IO unit. But if it is busy in doing its task internally, then it will not use this address bus and data bus, and that time IOM bar pin is tri-stated. Tri-stated means what? I told you before this also. What is meant by tri-stated? If this signal is high, at that time microprocessor is doing or communicating with IO devices, and when this signal goes low, same pin goes low, at that time microprocessor is doing memory operation. But if it is not doing any work along with this IO or memory, at that time it will be tri-stated, means its position is here. So it is neither low nor high, and that state is called as tri-stated. So when microprocessor is doing its work internally, at that time it will do address and IOM bar as a tri-stated. And address and data bus is, it means that address and data bus is not utilized by microprocessor. So what is DMA controller? DMA, I told you, DMA controller is the direct memory access. So whenever this DMA controller wanted to access the address bus and data bus of this 8085, at that time it will send the hold request signal. Hold is the request which is sent by DMA controller to 8085 to take the hold of system buses. Okay, and if microprocessor tri-stated IOM bar, it means that it is not doing any work with IO or memory unit. At that time it will send the acknowledgement signal to HLDA by sending HLDA signal to this DMA controller. HLDA is the hold acknowledgement signal, which is accepted by DMA controller, and DMA controller by sending this HLDA, it will also release the control of this data bus and address bus towards DMA controller, and DMA controller take the hold of this address bus and data bus, connect with this memory unit and access the data, fetch the data or instruction from memory unit, and after finishing its work it will release the control back to microprocessor. So this is the hold pin. So what is the main task of this hold pin? Whenever any peripheral devices wanted the hold of system buses, at that time it will send the hold request. For example, I have taken here DMA controller. DMS controller will send the hold request to this microprocessor. How obedient this DMA controller is that he is requesting for the hold. He is not वो छीन के नहीं ले रहा है. Okay, so it is requesting for the hold of the system buses, and microprocessor is not, if not doing any work, at the time it will release the system buses for DMA controller by sending hlda signal, and DMA will do it work. Okay, so this is about hold and hlda. Got it? Next, reset in bar. So reset in bar is the signal which is also externally initiated. So every microprocessor having, even your mobile having reset bar, reset pin, your computer is having reset pin, but who is pressing this reset pin? User. So that's why reset is externally initiated signal. So it will be externally initiated. If someone press the reset button, at that time what happens in microprocessor? Microprocessor having program counter which becomes 000, which becomes 0000. What is program counter? Program counter is a 16-bit register. It is a 16-bit register which is inside this microprocessor 8085, and its task is to hold the address of next incoming instruction. Okay, but suddenly if you press reset button, at that time this program counter will not hold the address of next instruction. Instead of that, it will hold the address of beginning memory location, that is 0000 is the first memory location which is holded by program counter. So, and microprocessor becomes resetted. Microprocessor is started from beginning, and this concept is called as reset in bar. And when it is activated, here bar is also there. So what it means? It means that reset in is active low signal. What is it? It is active low signal. When this signal goes low, microprocessor program counter becomes 0000. It means that it is holding the beginning address of this memory location, and microprocessor internally resetted. But after this immediately microprocessor send reset out pin. So this pin is there. Here this one is the pin, reset out pin, third number pin is there. So reset out pin is used to reset whole circuitry, reset other peripheral devices or memory unit which are connected to this microprocessor. So microprocessor will send immediately reset out pin to rest of the circuitry which is connected to it, and like this whole system becomes resetted. Okay, so this is your reset in and reset out pin. Now third one is ready pin. This is your microprocessor's chip 8085, and this one is any peripheral device, and whenever this peripheral device wanted to send or receive data from this microprocessor, at that time it will use this ready pin. Okay, so what is the main task of this ready pin? Why we are using ready? So here ready pin is utilized to synchronize the task between this slow peripheral device with fast microprocessor. Okay, so microprocessor is fastest device, while any peripheral device like keyboard, mouse, printer, scanner, whatever it is, their speed is too slow as compared to microprocessor. But whenever microprocessor sending or receiving data from this peripheral device to and from this peripheral device, at that time microprocessor should go into the wait state until that data reach to it. Okay, why? Because first of all, when microprocessor wanted to communicate with the suppose keyboard, it will send the address. Okay, then keyboard get activated and then it will send the data, and that data will be put it on data bus and will be dispatched towards this 8085. And but this takes too much time, this process takes too much time for this peripheral device. So at that time this ready pin go low, it indicates that microprocessor is waiting for the response. Okay, waiting for the response. And when microprocessor, when that peripheral device put the data onto the data bus and microprocessor sends it, at that time it will make it high. It indicates now data is onto the data bus and microprocessor will accept that data. So this is the ready pin which is used to synchronize the task between 8085 and slow peripheral devices. So microprocessor should wait until data reach to it. Once and when it is waiting, at that time it will make it ready pin low, and when data is sensed onto this data bus, at that time it will goes high and data will be accepted by microprocessor. It means that its wait state is now released. Okay, it will come into this active state. Okay, so this is your ready pin. Thank you.